Hi everyone, welcome to the 52nd session of Python for Machine Learning. In this session, we will learn about polynomial linear regression. But first of all, I'll explain you what is a polynomial equation. A polynomial equation is a function such as the quadratic, cubic, and a higher order equation where you will have more than one variables like independent variable like we have here in the first equation. Here in the first equation you have this y is equals to b0 x0 b1 x1 till b and xn. Okay, polynomial linear regression is an equation in which you have your number of input variables will be only one and the number of output variable will be one, but the degree of your equation will increase. So you can see here whatever we have, the value of x2 becomes x1, x1 is the same, again x0 will become 1, x3 will become x1, xn will become x1. So this is like a normal the condition in which there will be only one input variable. Now I will explain you through Excel how this polynomial equation the change. Suppose we have these numbers with us. Okay, we have the number xy and then we'll insert a scatter plot and then we add a trend line. If it is a linear, and we'll also add a equation, display equation on chart. So if it's a linear, then this is the equation, but if it's a polynomial, yeah, if it's a polynomial of degree 2, this is my and this will be my equation, and if it's a degree 3, this will be my equation. If it's a degree 4, my equation is this, and if my degree is 5, this is my equation. After that also their value, but it won't change even after that. If you try to change, it still remains the same. So the maximum like which it's supporting here, it's 6, and even in my tool also, or in my the Python program, there won't be much variation after the value 6. We'll take this value of x and y and we'll move to our Python programming, and this is the equation which we have got while in from the Excel, like how we, if the degree is 1, this is my equation, if the degree is 2, then this is my equation. And we will also run our Python program and we'll generate these coefficients and the intercepts both. So let's start with it. We already have the same x and y, whatever we have created there, we'll import this. Then now we'll print like what is the value of x. We already know here x is and y is this. Very basic thing is we'll plot our values, plt.plot x comma y. Just we'll plot it as a point. So this is how our this normal distribution of this x and y value. Now if we want to get the equation right, we need to create our equation for multivariate thing, for multiple degrees. So we need to fit this values. Okay, for that we will have coefficient hyphen intercept 1, this is equals to np.polyfit. This is for polynomial equation. We'll give the value of x comma y and we'll pass in the degree of our equation, and similarly we'll repeat it for 5 times because we want to get the like degree till 5th degree will go. And here also, like this is the place where I need to specify the degree. 4, 5. So now if we execute this value, okay, so our 5 coefficient value is executed. Now we'll print them and we'll verify with the above values here. Okay, we'll give print. Similarly we'll do it for like 5 times, we'll print them. Now if you see here, the very first value of my like coefficient and intercept is 0.33214, and here if you see the value is matching. The next value is minus 0.17, it has round off till third decimal position, and after that we have 0.439, then we have 0.3857, and similarly for the rest of the values it is matching absolutely correctly. Now like the coefficient and intercept for the respective degree is achieved, we need to simply plot. So for the first degree, if we plot plt.plot x comma y comma, similarly for the second degree, we have to give x comma numpy.polyval is a function where we need to pass the coefficient, which is our coefficient and intercept 1 comma the value of x, and we'll give it as blue color. Okay, similarly we will passing the respective coefficients, and we change that like color is red, yellow. So first of all, they will give here. We execute this shift and control enter. So this is our initial plot. This is our initial plot followed by this next line. So this is our linear regression, like first degree, the second line. This is our quadratic. The degree of equation is 2. This is the cubic. The red color represents the cubic. Okay. Now fourth degree. You can see the yellow one. The yellow line is representing the fourth degree. And if you want to see the fifth degree, which will be tan, which is this one, this line. So you can see. So this is how you will plot your polynomial regression and your points, and you can visualize your curve. Now this does not end here. We will also run a for loop for I in range 0, 5 colon. Then we'll give print degree is I. Then we'll give p is equals to np.polyfit, comma, and then we'll give the x comma y comma I is the like what we have give here polyfit. First we will create the coefficient itself, and then we'll plt.plot. Similarly we'll give here x comma np.polyval, and then we'll give t comma x. Whatever we are passing here, right, we are hard coding it, the values, coefficient 1, coefficient 2. So it will make for each term it will get the value of the coefficient here, and it will try to print it, and we'll give color is equals to blue. So if we execute this, yes, so you can see. So for first degree it's a linear like normal straight line. For second degree it's slight curve. For cubic you can see. For fourth degree again you can see, and your fifth degree final this is like. So this is how you can, without using the basic intention of this course of this video is like to show without using sklearn how we can predict the value using the polynomial linear regression. Now comes the phase where we need to fit the points to our, so what will gain? We need to predict the points. Okay, what is my actual value and what is my predicted value? So what we'll do, y is equals to, suppose if it's a first degree equation, then y pred is equals to 0 into x plus coefficient of the, see this value whatever we are having here. Okay, this is my 0th index and this is my first index of that given array. If you see coefficient, what is the value of coefficient 1? So this is my, if I give COEF of 0, so it will take the first part, and if I give the coefficient of 1, then it will take the second part, 0.475. So ultimate intention is if y is equals to mx plus c, then we have the coefficient and the intercept, and simply we need to pass in the x value and we will get the out. If we have the second degree equation with us and the coefficient intercept, then it will be y is equal to b0 x1 to the power 0 plus b2 x1 to the power 1 plus b3 x1 to the power 2, and similarly it goes on. Okay, so this is my y pred. So what is the value of y pred? And if you see what is my actual values, so you see the 0.47, the first line is the predicted value is this, and this is my actual value. Okay, so for my first degree equation, if we change the degree to this second, what is the value? There will be 3 values, right? So first value will take the 0th item, which will be the to the power of 2, and then say respectively we will take. Okay, and again, so if you see here, now the margin is decreasing between my actual value and my predicted value. For first, this one, the predicted value was 0.475 and the actual value is 0.2, but now it has decreased to some good extent. Similarly, for the others also, it is getting going quite near to that. This is how we will use the polynomial linear regression without using sklearn. Now we will use some formulas to determine my squared error and squared error. So what is that actually? see, my r square value is equal to 1 minus sum of the residuals. What is the sum of the residuals? If you go here, okay, see, this is my degree of the curve wherever my like curve is. This, if you see this value, this is my actual value, and this the value where we have this blue dot, this is my actual value, and whatever this curve will predict will be my predicted value. So difference between these two will be the residual, and we need to take the square of those residual. So r square is nothing but r square value 1 minus sum of the square of error by sum of the this value difference between the distance from the mean. You get the difference between the actual value from the mean for each point. So what we will do, calculate y reset, y residual, and then what we will get, sum of residual is equals to sum of power y comma, and then we'll execute this two lines. So what is sum of, okay, 0.4. Now we will get the for the denominator here we also the different sum of the square of the difference between the actual value and the mean value. Sum of total, which is equal to sum of the, or you can say length of y. So now square is equals to 1 minus, you can see r square is equal to 1 minus sum of square of the residual divided by sum of the square of the difference between actual and the actual value and the mean value. So our r square value is this. Now we'll use the scipy method, and from there we will verify. So from scipy dot stats import linear regress, and then we have to store all the values, the slope and the intercept, everything into the corresponding variables. Slope, intercept, r value, comma, p value, comma, standard error, comma, which is equals to, so you see the value matches. So this is how we will calculate the r square, and both manually what the formula which we have used, and also we can verify using the linear scipy.stats and import linear regression, and then we can verify. So this is how like we can use the Excel to verify again, and we can create our plot and then plot it in the graph one by one, and achieve the whatever we want to achieve using, or predict the values using the polynomial linear regression. So thanks a lot for watching this session. If you feel this video is helpful, please press the like button and subscribe to this channel. And in the next video, I'll be coming up with polynomial linear regression using sklearn. So see you in the next session. Thank you.